Welcome to Teaching Artificial Life for Industry. So I'm Tom Bartley. My longest serving artificial life project in ALIFE is known to some here. In addition, I have the FreshSim forum, which came out of the Biota project. There was a request for a forum, and the owner of the Biota site would prefer that it would be done externally. And I also work for Netflix. In addition, I'm the chair of the International Society for Artificial Life's Industry Outreach Group. So, you are the workshop. This workshop is being recorded, as the last one was. If you would prefer not to mention your full name, please use your first name. If you would prefer not to mention where you work, please use the industry area. This was based on the assumption, in the last workshop at least, that there would be people from industry attending. And if you just want to observe, I think basically with the group we have collected, it's going to be an active group. So the proposed structure, which I think we're probably going to dissolve from this group specifically, was who we are, introduction to experiences, the definitions of industry and artificial life, some feedback from the previous workshop, some discussion associated with various groups with survey expectations and concluding thoughts and the next step. The history of this group came from a work group that I formed in 2009, separate from the International Society. We had about 50 active participants. The two main outcomes from that work group was a survey of artificial life courses that were being taught internationally at the time. And basically what was being taught there, with the view not to have a unified artificial life curriculum, but basically to have a set of possible curriculum aspects and some feedback, particularly with regards to use in industry. So the curriculum could evolve, and basically people who went through either an undergraduate or graduate set of artificial life courses or a single artificial life course could use the skills that they had developed in industry as well. The initial surveying seemed to indicate that it was primarily historical works that were being presented. Larry Yeager, for example, had a very interesting course that related to seminal papers in particular areas in artificial life. We'll go through some of the problems associated with that kind of perspective, and certainly for those who attended the first session, you'll get a keen sense of why that may be problematic. So I think I have a rough indication of who we are, but the thought experiment was basically, are any of us from industry? Are any of us in academia? Some or all of the above, and what are our areas of interest? I will go through the areas of interest though. In terms of areas of interest, soft artificial life, show of hands.
I kind of don't know what the terms are more.
Okay.
Let's put it, or maybe I have a different understanding.
Okay, this is important because basically we all have different definitions. Soft artificial life is artificial life in software. Hard artificial life is robotics. And wet artificial life is the emerging, biochemistry manipulation element. So out of these three,
I do soft and hard.
Very good.
And academia, obviously.
Okay. And in terms of the amount of time that you devote to artificial life, full-time, part-time, not current?
That's difficult to answer because I work on evolution of artificial intelligence and consciousness, and with a heavy emphasis on evolution and cognitive systems and cognitive science. And yes, I think that field is definitely rooted in artificial life, and I would call it artificial life. At the same time, it sounds very much like cognitive science and evolutionary computing. So, yeah, somewhere in there.
Exactly. So, say part-time, basically, in yes. So I'm Tom Bartley. I currently work for Netflix. About a sixth of my time at Netflix is spent doing intelligent agents and things that link with Noble Ape in that regard. And a large portion of my after-hours time is spent with my artificial life project Noble Ape, in terms of open source contributors, general direction, feedback, and quite a bit of bug fixing as well. And I have a variety of experiences with artificial life in industry. My simulation Noble Ape has been used by Apple and Intel and potentially Google and a wide variety of other companies. So I've had some insight through that interaction, and obviously my current experiences in Netflix are also framing some of my experiences in industry as well. Go around the room for introductions and experiences.
Well, okay, I work with Chris Adami on, we started working on evolving artificial cell model in order to understand concepts that you can classify as modularity, structure, how networks are organized, graph theory, all that revolves around how complex systems are made, and the fact that they are sort of networks rather than stream. And from that we went to evolve not artificial networks, but something that we call a Markov brain. Essentially, it's some kind of hidden state model, or hidden state Markov model. So hidden Markov model, that's the correct term. And basically the claim is that engineering doesn't get us to artificial intelligence systems, because intelligent systems are extremely hard to engineer. Let's use evolution to get there. And every question along that line. And in parallel to that, because we're interested in consciousness, we also try to come up with objective neurocorrelate measures for consciousness, rather than the classical Turing test type of idea, because we have to get away from that sort of very subjective test to some objective things.
Are you based here?
Yeah, I work here.
Terrific.
I'm Carlos Anderson, and I work with the Biota system to look at evolutionary questions, specifically speciation, genetic mechanism of speciation. Charles Ofria is one of my leading writers. I also do some getting away from artificial life as a side project, or as a complementary project. I work with yeast populations to try to complement my work in artificial life with real biological life.
Cool. So, as for the first group, let's look at the definitions, because these are always interesting in terms of artificial life in industry. In terms of artificial life, a definition?
The definition of life is something tricky. But I guess I would try to make it very broad, and that is things that you're interested in biology but you can do in a computer, which would include things like predator-prey dynamics and differential equations, which look very abstract and don't resemble cells or something that would be populations. But I would put that in there as well. It's just a very abstract form. And of course, you can go to super specific stuff like whatever protein-protein interaction model on the molecular level, which also is some kind of artificial life, but it's on this very, very sort of micro level. And that's why I'm saying life that you can do in a computer is what we call artificial life.
I would just say anything that's, again, from defining life, anything lifelike that wasn't created by just nature, by natural means, but humans somehow either did it in a computer or artificially manipulating cells in order to get something like
So,
synthetic biology or something.
yes. I mean, as I did in the last group, you can start with Langton's definition of life as it could be. But I think the interesting thing associated with artificial life in industry is that it is a term which is rarely, if ever, used, and has a variety of meanings typically associated with media use, so Craig Mentler's work, for example. And it's a term that the community, I think, has never thought of as an external term that is being used in whatever way it needs to be used in. So certainly that's something we covered in the first group. Ideas what industry means in this context.
Maybe, I don't know much, but maybe they look at it like they look at genetic algorithms, a sort of method to solve a problem in a particular way, maybe in an evolutionary way, like genetic algorithms to solve a particular problem.
Certainly. And industry here in context means everything from startups to pharmaceutical companies to large software companies to everything in between, basically. An external commercial entity which normally should be making money. So So in the previous workshop, we covered a number of different areas. The first that I'll talk about here is the value problem. And the idea of the value problem is for an external observer, what is the value of artificial life? And value here is not an abstract value. It is something which is very heavily applied to what they are doing currently. So they will have an existing system that is not artificial life-based. They will see a value in that, and artificial life needs to improve the system in some way or give them something additional which conveys value to them exclusively. And the value problem is an interesting thought experiment because, as we did in the last group, and certainly this was my feedback for this group as well, a few basic thought experiments. I think we used eBay, Google, and Zynga as companies that exist that have specific needs that artificial life can present different solutions to and improved solutions in some circumstances. So doing those kind of thought experiments really focuses on the idea of value in a very pragmatic sense associated with a specific industry and how you use artificial life in that context.
One quick question. Are genetic algorithms considered part of the artificial life?
So this is interesting. At the conclusion of the last session, I was asked about machine learning and the components of machine learning. I think it's one of these things where if there is anything that distinguishes artificial life, it's the ability to use all of these components together and kind of lays off the underlying components basically so they all work together better. I think genetic algorithms I would consider part of artificial life, but they are used independently. And if used in isolation, then it's more questionable about whether they are specifically artificial life. If you have something that motivates the genetic algorithms, or that there is some, like an RNA-like structure, or something that is basically motivating the genetic algorithms, and you kind of have a combination of these things together, I think that's more sympathetic, or people may be more sympathetic to it being more artificial life. Now, genetic algorithms, I think, untuned or just kind of scattered, are probably genetic algorithms. But when used with other elements, as artificial life practitioners do, then they become more clearly artificial life. Certainly, at the surveying that I've done at Netflix, for example, I've given seminars, one on genetic programming, and probably 60% of the people in the room had an understanding of what genetic programming was. Contextually, applications, the selection of unload functions, these kind of things, not so much, but they at least had general knowledge. I think typically through most kinds of engineering and computer science, you will encounter some genetic algorithms which may not be framed in artificial life specifically. But in framing genetic algorithms together with a wide variety of other components, yes, I would consider it artificial life. In industry, it's seen as something different, but then again, genetic algorithms aren't fully exploited in industry currently, I don't think. And I think that's an artificial life component. The basic implementation of genetic algorithms don't necessarily give you the full optimization associated with genetic algorithms, the choices associated with what you attribute genes to, but also, are you familiar with island population densities and the way that they use those in terms of actually avoiding peaks in genetic algorithms? I mean, there's a lot of additional work in there, which I would say is thoroughly artificial life and does not in any way relate to genetic algorithms normally, because there you are using biological principles to really tune them heavily. So, yeah, it is a continuum, and genetic algorithms is an interesting one in that context.
Can I add something? Mm-hmm. Because it actually creates an interesting problem in academia, because the biologists usually are interested in evolution as a process and don't want that process be corrupted or modified in any way because they're studying the process. Mm-hmm. And of course, the engineers would like to get to results fast. Mm-hmm. Just as a rule of thumb, that's why they try to optimize the genetic algorithm. So you can use this genetic algorithm in two very different ways, either to study evolution or to get to a result. And of course, that discrepancy is really reflected here, because in industry you would like to apply and you don't really want to know something about evolution. Right? Mm-hmm.
Mm-hmm. So we discussed the recognition problem, and that relates to a variety of things which which have their roots in artificial life, both explicitly through artificial life publications and also implicitly through, as we're describing, the grouping phenomena. And the fact that these are not explicitly described as artificial life, and some examples were given, I think the two examples I gave were both from the games industry, but circumstances where games have come out that have had clear connections to artificial life algorithms. In some cases, the USC case, there was a direct connection to Jeffrey Ventrella's work, for example, but there was no attribution given. Similarly, there's a kind of legacy in game development of using artificial life elements, but not actually giving any kind of discussive attribution. So the recognition problem was more a discussion associated with what artificial life practitioners should do when they encounter this, and also we didn't really talk too much about the media, but something that I've done quite a bit historically is when articles come out. There was an article that came out maybe 2 years ago about a fellow who'd done a very simple cellular automata simulation, and it was released in a press release as being particularly groundbreaking, which just, the context was completely lost in terms of the legacy of cellular automata in an artificial life context. The legacy was completely lost, and I contacted the specific journals. I used to do this periodically as part of my work with Biota, as a means of just, you need to have friendly contacts in the journals community in order to get a message associated with artificial life out there. We discussed the quality of life, which is really important in terms of industry. The historical legacy of artificial life, and I made a couple of high examples. The continued kind of maintenance and development of people who are involved in artificial life requires a sense of the quality of life and what you need to do in order to maintain the quality of life. Here we're talking fundamentally about employment and salary in industry, but also just, I guess, strategic skill sets, these kind of things, which we discussed with the quality of life. And then we looked broadly at the skills required. I think the outcome for exploring the general skills required, the skills required in soft, hard, and wet artificial life was that when you come to industry, you need to be extremely competent in the skills that you require for that particular industry. So, for example, in the case of, let's say, eBay, certain aspects of web development, SQL Server, you need to be basically highly competent already in the skills that you need, plus have this artificial life component. And certainly my own experiences with Noble 8, what I've found from graduate students in particular is that they're very well-versed, or relatively well-versed in the history and the papers and these kind of things, but when they see actual software, they tend to balk. They tend to not get a sense of software development process and all the other things which really come through industry and are prerequisites for entering industry. So that's what we talked about with General. We also talked a little bit about outreach, which I think was an interesting point, that academics and folks publishing in artificial life should consider that a number of the companies that we discussed, a number of large companies, will actually allow people to come and speak. So rather than seeing the industry as a barrier, one of the ways to actually get into these companies is just to offer to come and talk about a particular subject. And within the artificial life community, there are a number of subjects which are applicable to a wide variety of these companies. It just takes that kind of outreach. And through that, you create contacts and go on to build an interactive community. Do you actively teach artificial life courses currently?
Not as a class, but I mean, all our folks, so to speak, in the lab gets supervised.
Can you describe that process?
Okay, that might sound cruel, but we basically seriously more or less confront somebody with a particular task that he or she is interested in, and say, I would like to evolve X. Mm-hmm. We provide, say, you should use this type of software, you should that type of software, maybe you should write your own simulation and so forth. let them struggle with that for a while. So I'm saying struggle, but that's the plural part here. Because as you mentioned, there are things that you have to understand, which means you have to understand the code, you have to understand these things, and it just takes a while. And there's nothing you can speed up about it. It's just, encouragement and help. And then usually all our students at some point get to this point where they start evolving things and start working, which is the complete usual experience, because designing fitness landscapes isn't easy. It requires a lot of experience and a lot of know-how what to do. And then we help them through that process. And that's how they develop this intricate knowledge of the software, same way with the sort of scientific questions behind it. So, yeah, it's more of a guided value crossing.
So as a student comes to MSU, do they have a sense of the Avita legacy? Do they have a sense of the history? And if an undergraduate student came to MSU, would they encounter any artificial life in their undergraduate studies?
I think they do, especially, I don't know so much about undergraduate, but graduate students, especially because of Beacon, grad students that enter Beacon, they offer a class that if you have a background in biology, they teach them all the basic computational tools they need to do research in a mixture of biology and computational stuff, including they also teach the basics of Avita and those courses. If you're a computer scientist, they teach you the biological part. And then in the spring semester, so and in the fall, but in the spring semester, they combine these biologists and computer scientists to work on collaborative projects that a lot of times end up being in Avita or any other system. But through that process, they're learning how Avita, not so much the code, but at least how to use Avita and get experiments running in Avita.
Do you know Jeff Bloom at all? Okay, so I talked to Jeff quite a bit because Jeff interested me with his background with Avita, but also because he gave an interesting account of MSU through the process. And the thing that interested me with Jeff was when he picked up neat and hyperneat from what he was looking at. I guess my concern with that approach is that it's very Avita-centric. And the kind of problems that Avita solves currently are, well, demarcated, but they're not necessarily the full breadth of problems that artificial life can solve. What I find fascinating is the number of sustaining projects out there, which Avita is obviously one. And my feedback would be that the plurality of projects would create natural ebbs and flows, which would probably improve a lot of the stuff that was being done fundamentally. I think Jeff Bloom's work in particular really flourished when he discovered neat and hyperneat. And it would be nice, and certainly this came up to the discussion of Avita at the end of the last session, it would be nice if Avita was to be a toolkit, that it was a toolkit, basically, and enabled access and plugging and taking these components and all these elements. And I guess my feedback, and obviously I have some sense of horse or a dog or an ant in the dam, would be that if people naturally progress to a wide variety of the simulations, that Beacon became ability for all the projects that are worked on to be surveyed and students to be put to them and these kind of things, I think it would strengthen Avita as well. The Avita monoculture here is it's the primary reason I'm staying for an additional week, because I think certainly my experiences with Noble Ape and the graduate students and postgraduates and folks that I get through Noble Ape seems to indicate to me that if MSU not necessarily had Noble Ape as part of that, but provided a series of simulations, Polymorph is another good example, then it would be doing a real service for the community and also probably strengthen what Avita was doing as well.
It would have been helpful, for anybody, just because when I first came here, it was all about Avita, and so I didn't get exposure to anything anything else. So, you know, a lot of people that also come
Yeah.
here, they're basically confronted with a Vita and they end up working with something on a Vita and not maybe something else that might have been better or more logical to use.
So,
I can sort of comment directly on that, because when I came to Trizagami in 2006, the first thing that we did was decide not to do a Vita. Deliberately, because the Vita is not a very good toolkit to do complex networks. It just doesn't work like that. That's why we made artificial cell model, because that's more biological in terms of networks. And sort of after that, we did evolutionary game theory, again, not using a Vita, using our own artificial game engines, so to speak. And then we moved to MSU, and now we are exposed to all the people who think Vita is the one solution to everything, encountering many difficulties, because sometimes it's just easier not to do Vita. But there is a big drawback, and that is the moment you do something on your own that is not a Vita, there is no precedent. You have to publish your descriptive part of your software with your first publication. You have to sort of not only sell the science, you also have to sell the system. Whereas if you do a Vita, you do not need to sell the system.
okay.
Even though
So let me talk on that point exactly.
Unless you're publishing a biological journal, you do have to sell a Vita.
Okay. So, yes,
Okay, yeah.
without question. All the projects that I'm mentioning all have that first paper. Polyworld has that first paper.
Yeah.
They all have that first paper.
Right. It's just so much easier for, I mean, if you are the grad student, you have to make a decision. Do I do my own? Meaning I have to publish something on a sort of first paper base, and I have to describe my stuff as well, or I just, quotation mark, go the convenient way and publish something with the framework that exists. I just go the convenient route. Even though that actually might screw up the actual experiment way more. There's so much stuff out there that it's a little, I don't want to say Vita heavy, because most of the time the science is absolutely solid, but there are all these intricate problems, quotation mark problems, that come with this thing being involved in a Vita and not in a sort of neutral system.
So, to your point, you're right, if you do a new project, without question, I always think actually that those first papers are really an important part of, it seems strange to me that is considered in some regard an obstacle, because I think that is really critical in terms of your introduction to an intellectual community. Now, it is challenging, but it also is something that I would have hoped that would be embraced basically as a welcome into an intellectual community. Of the projects that I've mentioned, they all have those first papers, though. So you're right. If you're doing something new, you have to do that. If you're picking up one of these other projects, the references are there, basically, which is really more my question associated with the MSU programs, is that if you have projects that have dated back to the 90s that have published work all the way through, why can't you at least include that in organic surveying? Because certainly the way, when I interviewed Jeff Bloom, and I've corresponded with him since, I wanted to talk to him about Avida. And he very quickly moved past Avida to talk about Hypheny, because that was what he was working with at that time. And it was clear that he, as you've noted, basically, he was slightly jaded.
He was always, I remember, we overlapped like a year or two in our Avida meetings. Whenever a new person would come up and present or propose research in Avida, he would always be the one to be like, why are you doing it in Avida? You have to do it in Avida. Can you do it in something else?
Yeah. So
I mean, there's going to be sort of, not a change, but sort of an interesting event going on, because usually the course that you're talking about, the Beacon evolution computation, is usually taught by Charles and Ian. But Charles is going to be in sabbatical, so Chris is going to teach that course, which basically means that his crew has to do that, and we are all non-Avida people. So I'm kind of curious what will happen, because there's this strong tradition to do Avida. I mean, there are so many reasons, because we have to prepare that thing. There's this sort of common knowledge about all these things. Everybody knows that it is an accepted toolkit, and it's just easier to teach something in an accepted framework rather than do new things all the time. So I'm kind of curious if that sort of tradition will change at least a little bit. Because
I didn't know about that.
So I mean, we have to do that at some point. And as I said, none of us is in the medium back in the US. So.
very good.
There's an option, so to speak.
I'll be spending extra time with you displaying Node 11. Good to know. Good to know. Okay. So I think what we've discussed here is something that is not unique to MSU, and I think when through the discussion from industry, the idea of the multiplicity of solutions is something that I think is really critical from artificial life and something that needs to carry on. My anticipation is that this recording will probably go further than this meeting in terms of the participants. But my sense is that, that there needs to be a plurality of solutions that are described. And I think the interesting thing about what we did this morning was, in throwing out thought experiments, I got the sense that, and these were graduate students and academics, that they had not done very basic thought experiments associated with the applied use of what they were developing. And that struck me very strongly that, I guess, when you work in industry, everything has an applied context. You can't escape from the applied context, because ultimately, it's not that you're trying to get funding, it's your existence, basically. And yes, it was quite striking in the meeting this morning. Could have been that it was 9:30 a.m., but still, that the participants, you could really see the kind of cogs in the mind basically associated with applied problem. So it's difficult to say in terms of a historical surveying of artificial life as it's taught. The actual applied uses, certainly another point that I tried to make through the meeting this morning was practical work. And that was certainly the component that seems to lead you more towards the application, was to create evolving predator-prey models, create ADAR simulations, actually do these things completely independent of some underlying project, just write software with artificial life principles and see what comes out of it firsthand. Maybe, it's a personal note, but I certainly got the sense from the group this morning as well that when you do something practically, it's very different than reading something in paper. So to take something that you've read in a paper and create something applied out of that, it's relatively abstract. But if you have a practical sense of, this is what a large-scale predator-prey with increasing sets of predators and prey, in terms of stability and these kind of questions, then it's a lot easier to take that knowledge and actually move it to applied fashion. So, from my perspective, nothing beats practical work in the context of teaching. It's going to be done to more people here, actually, because I'd be really interested in seeing or hearing from other folk. My anticipation is that this audio will go out and hopefully we'll get feedback. And I know this was they had swapped the sessions to do the teaching one first and the industry one second, because my understanding is that there are additional workshops basically that would push probably more people. So that could have been the artificial nature of the switch up as well. Others, I don't really have much more to say. Do we have any questions?
Just a comment. The thing is that we had this in one of the courses because I was teaching iPhone game development, particularly iPhone game development, because there's a product in the end that the students like to achieve. It's an app that you get out there and you get feedback and maybe you earn money. Mm-hmm. So there's this deadline that says at the end of the course you have to deliver a product. Mm-hmm. And that means that you cannot overscope and you have to focus on this thing. You have to get it out the door. And at some point you have to make compromises because there's either content that you haven't implemented or there isn't code that you have written. It created this urgency to actually come up with a solution rather than just have all the time in the world to write the nicest piece of software you can come up. And I see that as a sort of tradition from the people that come from the computer science side. Mm-hmm. When they approach VIA or any kind of ALIFE project, they spend a lot of time making very nice code. And I don't want to say waste them, but usually the code is very elaborate and very intense and reusable and has lots of options. And in the end, they use like 10% of it to actually make that final project. Mm-hmm. Now, I have exactly the opposite experience. I'm a biologist, and in biology, the experimentation times are very long. Mm-hmm. Until you do your next experiments, there are months that you spend on whatever, cloning, feeding, breeding, preparing, right? Now, when I come to computer science, I have this, or this type of AI, I have the feeling that I can do so many things so fast, and I don't write beautiful, great code. I write functional code that delivers the job, and I skip the 90% of maths. Okay, my code is not horrible, people can use it, there is some kind of minimal coherency there, right? I'm not exaggerating. But usually that means that I can write or make lots and lots and lots of experiments in short time, which is actually the currency in science. We would like to have a high sort of experimental turnover. Mm-hmm. And I just wanted to mention that this is not necessarily only an sort of practical versus theoretical approach. It's sort of something that also comes from the disciplines, mm-hmm. which is because biology is slow, now in computer science you can do fast, and computer science has the tradition of making beautiful code, but the currency is experiment. And in computer science, the currency is not necessarily experiments. It's beautiful code. So that's also sort of a tradition.
On your app point, the fascinating part of that is it's after the release that the real learning starts.
Yeah.
And I think that's the interesting thing that I've seen these courses that are taught, but it's actually after the release that you realize the user feedback and what you change as well. And that's an interesting point, which fits into artificial life too, that if you are developing as an industry, it's not a release point, it's a continued, basically, set of iterations after the initial point where it goes live. What typically happens is you have a series of A/B tests leading into that, where you have the existing one and your new one, existing one and your new one. You expose it to more and more users progressively, and then it goes live, and then you again do segmentation, A/B test, and iteration through. These kind of skills are really critical.
And in academia, you end up making your paper, and if it's a grad student, chances are nobody is actually reusing that code ever.
Mm-hmm.
So if that happens in a framework that actually exists, like Biota, then at least that part wasn't wasted because there was no new stuff that was made. It just so happens that that's the case in labs.
Part of this discussion has to be about open source as well, or at least the notion of what open source means in both a social context and an academic context. And I think my great frustration, and I've heard projects used here and also referenced from here, where they still have closed source. And
I mean, that's impossible, because if it's published, it must be accessible. And that's at least the responsible research guideline, right? And
it's not always the way, though.
I mean, that it's not always the way, and I mean, that's true with bioinformatics, right?
Mm-hmm.
We get scripts from people who say that, maybe that's the script, maybe it isn't, and you can't even run it because it is sort of 10 years old, and on data sets that you don't have anymore. So the reproducibility is completely not given in many of these cases.
Exactly.
At the same time, it must be, because it's published, right? So.
Yes, and I think that's a problem within the Artificial Life Journal as well, with the access to the source code. But also, when you put source code open source, it has a different relationship than it does as closed or even just single-time published in terms of the kind of iterative process. And I think the notion of dead code in this, even in coursework, is interesting there. I mean, it would be nice, and I guess that's what we're talking about specifically with Biota, is that most of this code is conglomerated. I mean, obviously some of it is cast aside, but I mean, that's what has created Biota as it is, basically.
I mean, there's a very nice course from Titus Brown who basically talks about making code reusable or actually opening up this entire thing. And I think there are these two base ideas where we share saying you have to use version control like GitHub or something like that, and make it public, make it usable. And at the same time, and we got sort of a positive notion on our latest paper about it, because he in the end wrote, IPython notebook script that everybody can run on an Amazon instance, so you don't even need your own computational hardware. You just pay your 25 cents to hire that thing. There's an image that runs, and this image will persist because Amazon supports that. And you can always redo the computation in a IPython interactive sort of form, because we know that we want people to use the software and understand it and be able to recook all of that. We want this open sourceness. And at the same time, it's good practice because it's redoable, right? You can always go back and say, that's what they did, that's how we do it, here's the script, everything is reproducible. And I mean, yes, that's a lot of work at a very high standard, but I would be happy if everybody does that. Because
I think it should be a requirement. And I think basically and this is going to come up on Sunday, I hope, the history of the International Society and the Artificial Life Journal has not always been simpatico, but the only way we can do it going forward is with that. I think it's critical, and it needs to be, primary, basically, in moving forward with the journal. Any more questions associated with? So, even prior to doing the first session, my thought was that students who enter industry need to be extremely proficient in whatever industry they're entering, plus have additional artificial life experience. The use of artificial life in industry, in terms of expectations, this is a difficulty, and certainly this is what we discussed after the last session. Currently, aside from various things we've talked about at Gecko and in other places, the kind of artificial life that folks talk about at this kind of conference isn't used in industry heavily. Typically, larger sized companies will not have any elements even of genetic algorithms in their approaches. And what you need to do when you enter one of these kind of companies is progressively, engineer by engineer, almost convert them by example to start using these principles. My experience with overlay at Apple was that it spread very rapidly amongst the engineers there because it was very useful for what they wanted to do in terms of tuning. So it developed very rapidly through word of mouth with the engineers there. It was also displayed at their Worldwide Developers Conference, so it had like public showing as well. But that was amazing in terms of just the speed at which it was picked up. So I think there are success stories in terms of artificial life moving through industry, but in general, a student who graduates should have a sense that when they enter industry, there may be components of artificial life that are understood there, but as a whole, not used, and probably it will be, the expectation is on them to own some of these algorithms, to develop techniques which show clear value, and to work through whatever political boundaries or other obstacles are there in order to see these things implemented, and then hopefully come back and publish them accordingly.
So for a student like me, where I'm just using artificial life to answer evolutionary questions, and I don't keep up with all the industry skills or proficiencies, how does a student that's graduated with a doctorate degree get into industry that they're interested in?
So
basically, you just have to make up time, learn all the...
in certain examples, I think there are skill sets that you will already have. My hope is, and you can do this practically by going to Google's website or Facebook's website or any of these companies' websites and look at what their data scientist jobs are like, what their scientist jobs are like, because that will have the PhD prerequisite. It will probably have additional requirements that you won't necessarily have. So you need to be very well versed in those things. It's difficult. Professionally you can actually, for app development, for example, there are lots of resources out there to explain the language of app development, all the underlying elements within the SQL community, the R community, the MATLAB community. All these communities, you can go on the sites, and if you can enter into a relatively abstract discussion and have a degree of understanding, or at least learn from that, you have a sense that you have at least the linguistic skill set in order to engage with people that are proficient. So my view is that you may have to do a lot of skilling up front in order to get in the door, basically, but in ways which are not in any way associated with your PhD or artificial life specifically. You need that proficiency. They're not, irrespective, the comment came up that in the last session that people from industry should come to this conference and appreciate the brilliance that is exhibited in this conference. What you'll find in industry is that there is no notion that there are smart people out there. The notion is that the smart people are all in the companies, and that you need to prove you're smart to get into the company. the notion that there is external intelligence that may be conveyed to you in a university setting or these kind of things is not immediately absorbed, or is not part of even the concept. So my view is skill yourself around what they're already doing as much as possible. I mean, obviously you can't generate 2, 4, 6 years worth of work in a relatively short time frame, but at least to show that you've done the basic learning. In terms of the recruiting that I've been a part of, even for the short period of time I've been at Netflix, people who come in, and this is typically app development and management of app development, this kind of thing, they need to at least be relatively familiar with the vernacular, and if they're not, there's no on-the-job training associated with that. Once you've picked up the vernacular, you pick up the on-the-job training basically being there. So you can pick that up very rapidly. Obviously, you're willing to do that. But you just need to be familiar with the vernacular before you present yourself. Some other feedback from the earlier group. My hope was that there would be more people here who were teaching artificial life courses. Because certainly the sense that I got from the initial group was that if they had gone through an existing curriculum, and there were half a dozen universities that were represented in the first group, that they all had come to artificial life from something that didn't really lend or lead towards industry fundamentally, and they were shifting frames quite distinctly in order to discuss relatively basic questions. So this point, I think, is really important as well. I notice that students who continue on to academia need to have a keen appreciation for the use of artificial life in industry and remain connected with industry. And I think that came out of the first discussion associated with actively going into companies, meeting people, getting a sense of what they're doing. Similarly, we discussed surveying papers and these kind of things to get a sense where people in industry are publishing and get a sense of their potential connection with artificial life or things that lead into artificial life, with a view of approaching them potentially for collaboration or at least for points of contact. But I think this, are there any questions associated with the expectations point, associated with students that come from these kind of courses? So we've done this considerably faster than I expected, but it's also due to the number of folk who are here. In terms of what we've covered today, any concluding thoughts?
Yes. It's more a question, an observation. It touches a little bit this expectation. And we talked about this briefly in the robotics session. And that the idea that once you have involved robots and you have a company that markets them and tries to distribute them, then of course there is this reliability or liability issue that you as a company produced something that was evolved rather than designed. And because it was evolved, you might not fully understand that system. It's actually the same reason why NASA JPL has problems sending up probes that have evolved controllers. Because if you ask me what this controller does, is I can describe that, but I do not know how it reacts in any possible way, how an engineered system could be understood, because it was evolved rather than designed. It's this implicit notion. And we weren't sure to what extent this is actually a fear or an actual liability issue, because, well, it was evolved, we are not really responsible for that behavior, even though we made it. And that's this fear, quotation mark, that.
So we discussed this also. The example I used was Toyota.
Yeah.
So you create an ALIFE system for some aspect of Toyota. How do you describe the safety component to it? Exactly the same point. The point I made with Toyota was human override, which is the way that they've been able to deal with it. But with military systems and these kind of things, you do sometimes have human override, but you don't necessarily. And I think this is a very interesting problem.
So, I mean, the thing is, I guess the question is, I mean, for NASA and JPL, this is definitely an engineering tradition. I mean, breaking traditions is always hard, and you have to convince them over a long period of time. I don't know if industry itself, other than space exploration, is actually that hesitant, because there are many, many advantages, and I think specifically evolved systems have this notion of being more robust and so forth, so they might even be safer. It's just we haven't demonstrated that.
Let's talk about game development specifically, because game development is fascinating associated with exactly that point. The fear within game development for adopting artificial life is twofold. The first is the sense it'll take a long time before anything interesting happens, which is what Will Wright has talked about specifically. The second is exactly the point that you mentioned. How do you actually test a game that has an artificial life component? Because it is potentially chaotic. It potentially could go in a wide variety of different directions. When you have a game that people are playing, there's a very immediate response if the game crashes or doesn't work or all these kind of things. So when I talk to game developers, I talked about testing as well. And what's interesting with testing is you can actually evolve testing for testing artificial life as well. The two can go simpatico, and you can actually run considerably more gameplay iterations or what have you if you have an evolved tester as well, which can answer some of those questions. You can write hard parameters in most of these things. You know, you can write hard parameters associated with human override, in the case of artificial life games, oftentimes these things are tuned for either over or under survivability. So you either need to actively participate in order to make something survive, or you need to actively kill things in order to stop things from surviving. So they're the kind of parameters in the case of game development. But yeah, when I talk to game developers from outside artificial life, who are sympathetic and interested, these are always the points that they raise, basically. And I think we can answer them in the ways that I have.
I guess, I mean, I just read an article, actually blog post on Biota, because where a guy discusses this following problem. You as a game designer can either open up the game and have the sandbox type of feeling, think about, what is it, Angry Birds, right? Mm-hmm. No Angry Birds game looks exactly the same because this thing crashes in different cases, but it's all within a sort of confined space. Nevertheless, it's random in its outcome. And the other faction of game designers actually tries to sort of embrace the fact that they design the game. They really want to have absolute control over every aspect, because then they can lead and guide the player much more.
Yeah, force narrative. Yeah.
Right. And I guess then it's just a matter of taste. I guess one of these groups will adopt earlier. There's the strict control freak quotation mark. Might be inspired by the Wolf story, but will then take that and.
The games that have longevity, and here I'm talking 5, 10 years, tend to be the games that initially either have some random element or have something which doesn't have a forced narrative. And in terms of then, if you want to talk about the modding community and a wide variety of other factors, they're added bonuses. But the problem with game development as an industry is that it takes the Hollywood model now. It's very much associated with the same model of producing films. It's about taking a certain amount of money, generating this thing, and selling it for a very short window. The long-tail games that we all think of fondly, possibly, are really very, very small part of modern-day game development. It's about taking brand, licensing, all this kind of stuff. The thing that interests me, and this came through the first session, is the Zynga and Zynga-like companies in terms of web games and this. All the startups that contacted me, at least, associated with this have been profitable. And it's a very simple model where if you added artificial life, you would have exactly what you describe in terms of an additional richness and probably a vast, well, although they're relatively successful because they are playable and addictive, but a depth which the current games just don't have. And I think the ability to create unpredictable environments in these kind of circumstances actually is a benefit in the long term as well. In terms of kind of, you want a certain level. When I first moved to the Bay Area, a decade ago, I spent a good amount of time with Steve Wozniak and his people, and they're very interested in obsessive nerd things. Things that people get really heavily obsessed with. Logo, turtle, logo, everything up in games. And the modding community and that interactive component is something, and certainly when I talk to artificial life game developers, people like Steve Grand and lesser extent differential, they're very interested in that component, the neat folk as well that do independent games. Yeah, I think there's a lot there, basically. And as you say, the chaos and complexity is actually what you want fundamentally. So, for this group specifically, my hope was also that we would gather together folk for the group, for the industry outreach group. And if you're particularly interested, please do keep in contact specifically associated with this. My hope also is as folks who listen to this audio would also consider contacting me as well in terms of, just moving this thing forward. The plan is to continue doing these workshops at future Artificial Life conferences and hopefully see the kind of progression of thought and discussion, basically, from what's happened here. So I was going to talk quite a bit about textbooks and these kind of things too. Unfortunately, I don't think the assembled group is really the context for that, but it's certainly a conversation that I have with Springer and other publishers associated with the cost of textbooks, what's within the textbooks, and the fact that people who are teaching artificial life tend to graze from a series of different papers, what have you, and if there was a unified, even potentially a set of textbooks that they could choose from, I think it would be a very different, potentially move into undergraduate as well in terms of how it was actually exposed. My understanding is, and when I meet Larry Yeager sometime at this conference, I'll ask him, but my understanding is that he teaches undergraduates as well at Indiana. And there are people that teach undergraduate artificial life courses as well. But yes, my hope was that they would attend this. So hopefully I'll meet them at another session. And that's all I have planned, folks. So thank you very much for attending. I can do a demo and a discussion for Noble 8 with you if you'd like. And you can stay for that too if you'd like. Thank you. I'll just add an echo effect. And,